What are Terraform modules? How do they help you standardize infrastructure as code? And how do they make engineers' jobs easier? If you found yourself asking these questions, then you're in the right place. We're going to have a look at why you should use Terraform modules, how to design them right, and how Spacelift can help you scale them across your organization. So, why use Terraform modules? Do not repeat yourself. Modules prevent you from doing the same thing over and over again. If you're a parent, you already know how annoying repetition can be. If you don't template your code, engineers waste hours reinventing the wheel and repeating mistakes. At scale, having each team craft its own VPC or ECS setup is massively inefficient and error-prone. Modules let you write a configuration once and have everyone reuse it, avoiding duplication of effort. Standardization. Modules help you enforce standards. Imagine debugging a network issue and discovering an app's VPC flow logs weren't enabled, despite your guidelines. If everyone used your VPC module that always enables logs by default, that issue would never have happened. And when you decide to change something, say those logs are too verbose and you want them off, you just update the module in one place and the change is propagated to all the places the module was implemented. Compliance and security. Modules are excellent for embedding security and compliance controls. For example, you can make sure that every S3 bucket your module creates is encrypted and private by default, with no public access. Using modules as guardrails means far fewer opportunities to accidentally expose sensitive information or skip a critical step, and auditors love to see misconfigurations prevented by design. Now that we've covered why modules are valuable, let's see how to build one properly. Suppose you have Terraform code for an EC2 instance plus its security group and IAM role. Instead of copying that for every new project, turn it into a module. Here's how to do it right. Name it well. Use a clear, descriptive name like secure_instance, and make sure you stick to a consistent naming convention, for example, lowercase with underscores. Standard structure. Organize the module in its own folder. Inside, put the resource definitions in the main TF, inputs in the variables TF, and outputs in the outputs TF to keep the module tidy and easy to navigate. Inputs and outputs. In variables.tf, define variables for configurable settings, AMI, instance type, etc., with sensible defaults and descriptions. In the outputs.tf, expose values other configurations might need, like instance ID or IP address. Keep the module's interface minimal, only what users actually need. Documentation. Write a README explaining the module's purpose and usage. List the inputs and outputs, each with a short description. A well-documented module is way more likely to be used correctly. Validate and test. Add validation rules to catch invalid inputs early. If possible, use CI to run Terraform validate, and even a test deploy on each change. That ensures the module works as expected before others use it. Using the module is straightforward. In your root configuration, reference the new module via local path, git URL or registry, and pass the needed variables, and then run Terraform. It will set up an EC2 instance with all the security components from the module. No more copy and pasting, and teams can now spin up a secure instance by reusing your module. Scaling modules with Spacelift. You've built a great module. How do you share it and manage it across teams and environments? Spacelift's Module Registry is perfect for that. It lets you publish Terraform modules in one place and makes them easy for your organization to discover, version, and control. Connect Spacelift to the Git repository where your modules live, ideally one module per repo, and Spacelift will turn that repo into a shareable module in its registry. It pulls in your README and auto-detects the module's inputs and outputs to generate documentation. So when others browse the registry, they see exactly what the module does and how to use it. No guesswork needed. Spacelift also provides built-in CI for your module. Every commit to the module's repo can trigger a test run, for example, automatically running a Terraform plan with your specified Terraform or OpenTofu version. This way you never publish a module version that hasn't been validated. Only code that passes checks becomes an official release, reducing the number of broken modules for your users. The registry also enforces module versioning. When you're ready to release changes, you publish a new version of that module. Teams can pin to a specific version so they won't get unexpected updates unless they're ready to upgrade. If a bad bug slips through, you can mark that version as deprecated in the registry to warn teams and block their use. Using a module from the Spacelift registry is just like any other module, except the source, something like this, and specify the version. Spacelift does provide a copy and paste snippet for convenience in the registry. You can also control who can access each module, maybe restrict experimental modules to a small group while exposing production-ready ones to all teams. This spreads best practices without losing control. In conclusion, Terraform modules let you standardize and reuse infrastructure code, boosting efficiency and reliability. You make your modules robust and easy to adopt. Spacelift amplifies those benefits by providing a platform for sharing modules at scale with automation and governance built in. The result is repeatable, controlled infrastructure as code, helping your teams move faster and with confidence. Thank you for watching, and try out Spacelift now at spacelift.io. Happy terraforming!